All right, number 23 gives us a graph and it shows a line segment FG and then point P. So let's just highlight that. Here's point P and line segment FG. It gives us some bullet points. It tells us that point M is located in the third quadrant. Hopefully you remember that quadrant 1 is here. This is 1, this is 2, this is 3, this is 4. So we're going to be located in this quadrant right here. All right, it then tells us that the distance between point M and point P is half the distance between point F and point G. So when I analyze that, it's telling us that this distance right here between M and P is going to equal half the distance that exists between F and G. So let's look at the distance that exists between F and G. F and G, if I go 1, 2, 3, 4, 5, 6, we take 6 steps here. Half that distance would be 3. So we're looking for 3 units away from our point. Now it told us that we're in quadrant 3. So would it make sense to go 3 units up, 3 units to the right, 3 units down, or 3 units to the left? The only one that lands us in quadrant 3 is going to the left. So when we count from here, let's make sure we go to the left. And it then says segment MP is parallel to segment FG. So FG, if it's running like this, a parallel line needs to go straight across like this. So that just further confirms what we just said about going to the left. All right, so from point P, let's go over 3 units. 1, 2, 3. And this is going to be the ordered pair for the point M. That's point M. Now, what is that point that we just graphed? We went over from the origin, we go over to the left 1, and then we go down 8. So this ordered pair is -1, -8. What is the first coordinate of point M? So when you look at this, it's asking for the first value there, and that would be -1. So the solution here would be D.